Okay, so before we get started into this problem, thank you for reading that, there's a typo on your paper. The equation should be this one here. They didn't find the typo till after I made copies. So the equation that you have on your paper won't give you the right graph, so make sure you change it to this. And then the next thing, are there any words from this word problem that you don't know what it's talking about? This is kind of golf-specific terminology. Anybody not know what golf-specific terminology? Okay. So what does X stand for? Time. What does G of X stand for? Height. So one of the first things we're going to do is add labels to our axes, including variable, description in words, and units. So X, we can see read from the problem, was time. That's in seconds. Our y-axis was height, and that's measured in feet. Okay, part B, focus on the equation used to model the ball's flight. So we're going to focus just on this equation right here. What do you think, or what do you predict the graph will look like? Yeah. So it's going to be a downward parabola. What part of the equation told you it was going to be a downward parabola? Okay, so the negative here tells us that our parabola has to go down. What else could you say about what this graph might look like? It's going to be narrow because of what? Because the 16 is much bigger than 1. So it's going to be narrow because of that 16. Anything else that you can predict or know about the graph without actually graphing it yet? There should be one more thing that you can see. The vertex. What's our vertex? 264. Okay. Anything else you can see about your graph? Okay. So, part 3, scale each axis so that all the important features fit on the graph. So, how high does my graph have to go? Up to 64. Well, I don't have 64 little marks. So, does anyone remember how you can scale a graph? Okay, but which one? Which one will guarantee everything fits?
You divide both by the same number. Both the integers on that vertex.
I'm not following.
Like 2 divided by 2 is 1 inch, 4 divided by 2 is 32, so it's going to be 132 if you want to.
So you're saying scale, we don't want to scale the points, we're trying to scale the graph. Okay, so the way that you can figure out what to count by, count how many marks you have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I have 17 marks. I need that highest one to at least be 64. So if I do 64 divided by 17, I get 3.76. So that means if I count by 4s, everything's going to fit. So if I count by 4s, so 4, and I'm only going to write every other number for space sake. So 4, meaning the second one's 8. The third one is 12. The fourth one would be 16. The fifth one would be 20. Then we go 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, And then the last ones I'm going to do 64 and 68 just so that we actually see 64 on our axis. All right, what about time? How much time do we need? So how did you get 64? Let's start with that. How did you know we needed 64? Because what? I think I heard someone up here say it. Because it's the y-axis, and what do we know our highest point is on the y-axis? 64. So what about the x? Okay, but if we think about, so here's kind of the trick. The 2 is only the halfway point when we look at a parabola. So 2 will just get us to the top. We have to get back down. So the kind of the trick is you double whatever your vertex is to figure out how far you need to go. So what's 2 times 2? So we need to show at least 4 seconds or 4 seconds on our x-axis. So what do we want to count by? This one we can count by ones. If you want, you can even count by 1/2. It's up to you. But we can do ones. So we'll have 1, 2, 3, 4, 5, 6. I'm only going to go to 7. So we're counting by ones. Your x and y do not have to be the same intervals. Okay, I just want to make that clear. Now, had we chosen, well, I'll talk about that in a minute. I'll talk about that in a minute. Okay, so we've scaled each axis, and now we have to actually graph the parabola. So we know that our vertex is at 264. And then usually what I'll do on these kind of problems, so you can see it, is I'll figure out how high was I when I started. So I'll plug in 0. So if we plug in 0 to this equation, negative 16 times 0 minus 2 squared plus 64. Negative 16 times negative 2 squared plus 64. Negative 2 squared is 4, so negative 16 times 4 plus 64. Negative 16 times 4 is negative 64 plus 64. Yeah. We're starting at 0. So at time of 0, we are at 0 feet. But what does that also tell me, though, when I reflect it? So this was 2 away. So if I go 2 this way, to the left, I'll also be at 0. So does our graph kind of match our description that we made in B? Is it a downward parabola? Is it narrow? And is the vertex at 264? Yeah. So what I was saying earlier about scale, I'm going to give you the same graph with a different scale. So here we counted by ones and we counted by fours. Here's one that's counted by ones, or sorry, not counted by 1/2. Do those look the same? What's different about them? One's a little bit wider, so it doesn't look as narrow as you might think. Okay. The reason I want to show this to you is because depending on how you choose to scale, because we might not all choose the same scale. When you choose a different scale, you might lose a little bit of the shape because you're either widening out your x's or you're squishing down your y's. Okay, so just keep that in mind, that if it's not a perfect match to your description is based on if you're counting by ones. So once you start changing that, your graphs might look a little different, but as long as your key points are correct, then your graph is correct. So when it comes to graphing these and when I go through and look at them and grade them, I'm going to be looking more for the same key points. So it crosses at 4 and 0, and the vertex is at 264. Same points as here, just different scale. Okay? So if you're doing this, or when you're doing this on your own, if you choose a different scale than your friend, your graphs might look a little different, and that's okay. All right? All right, so on to D. Why does it make sense that our graph is only in the first quadrant? So why does it make sense that we're only over here? And I want someone I haven't heard from yet today. Malka?
Because it's all positive.
What's all positive?
The time can only go up and then the height can only go up.
Okay, so anyone want to kind of rephrase that? You're right. I'm looking for a very specific word, and you're almost there. Joe?
What the height means I start at 0.
Okay. Anyone want to add to that? Skylar?
You can't go negative time and negative feet.
You can't go negative time and negative feet. So that negative is the key word. Because can you be negative 2 seconds into your hit of a golf ball? No, it makes no sense. Okay, so why does it make sense that it's only in the first? Because time can't be negative. And height can't be negative. So Jill and Malka, what you were saying was right. I was just looking for that word negative. Okay. So, domain and range. If we just said time can't be negative, can our domain be all real numbers? If we just said time cannot be negative, can the domain be all real numbers? Okay, because what can't time be? Negative. So it can't be any number. We have a restriction. This only happens when we have the context of a problem. So everything we've done before hasn't had a context. It's just been here's an equation, graph a parabola. We had no context as to what it meant. When you have a context, you might have a domain restriction such as time. So if time can't be negative, then our domain has to start at 0. Now, is the ball going to fall forever? Or will it eventually hit the ground again? It'll hit the ground and then time stops. So when does our ball hit the ground?
4 seconds.
After 4 seconds. So the other one. So we know it hits the ground. It starts on the ground. It hits the ground again at 4 seconds. So your domain is going to be between 0 and 4 seconds. Because after 4 seconds, we say, okay, the ball's on the ground, on to the next shot. It might roll a little bit, but it's still on the ground. Okay, what about the range? Chase?
0 is less than or equal to y, which is less than or equal to 64.
Good. So our ball is going to start at height of 0. It's going to go up to 64 feet before it falls back down, back to 0. So you're never going to be negative. So that's what the zeros are telling us. So you're only going to have this kind of domain and range when you have context problems.
What if like the ball was like the sand pit?
It's still on the ground though. We're not talking sea level.
Okay.
Because that's like sea level, but you're still on the ground, and your height is now still considered 0. So we're kind of taking that part out, the whole sea level part of height, and just saying hitting the ground. All right. Any questions so far before we go on to the kind of the more challenging questions? Because number 2 is going to be asking you to do all this exact same stuff, but with a different contexted problem. You're actually going to be talking about a farming problem with peaches and peach trees. Okay, so let's answer these. What is the maximum height of the ball?
64.
How do you know that? But how did we read from our, where did it say that? In the vertex. So how do you know? It is the y value of the maximum. How high is the ball at 3 seconds. So how might we figure out where it is at 3 seconds?
36.
You sure about that?
I don't know.
So if we try to read our graph, we might have to estimate because we're not 100% sure because it's actually not 36, but you're not far off. How would we find out for sure how far it is? Plug it in. So we're going to plug in 3. So negative 16. 3 minus 2 squared plus 64. So negative 16 times 1 squared plus 64. Negative 16 plus 64.
Where's the other part?
What other part?
The middle.
This is the equation that we started with.
Yeah.
Everything's coming back to this equation in the problem. We're plugging 3 into that equation. So when we plug in 3 minus 2 is how I got 1. And then 1 squared is 1, so this is just going to stay negative 16. And then I can add 64 to get 48. So at 3 seconds, it's 48 feet in the air. How long is the ball in flight? 4 seconds. How do you know that?
Can't figure out the 4 seconds.
Hmm?
Can't figure out the 4 seconds.
Okay. I think. Anyone else want to offer how you know it's 4 seconds that the ball is in flight? Where were we at 4 seconds on our graph? Back at 0. So because according to our graph, we hit the ground again at 4 seconds, meaning from 0 to 4, it was in flight. So the y would be how do you know? That is when the parabola hits the x-axis a second time. Okay, that's all one problem. Number 1. Okay. So, yeah.
Letter C, can we always use
Yeah, I usually do, just because that way I can figure out either at time 0 or like in the next one where it's talking about trees. It's like, how many peaches will you have if you have 0 trees? Logically, what should you think? 0, but plug it in to make sure that that happens. So I usually do that just so I can see what am I starting at 0, and then that gives me a reflected point. Sometimes if it's a really big number, I might choose another one in between just so I can get a better idea, but you don't technically have to. All right, so if you flip the page to number 2, you're going to do number 2 on your own, but you're going to follow the same process, all the same questions as number 1. Then you'll move on to 3, 4, 5, and 6. And 3 is only a 3-part question. 4, 5, and 6 are 1-part questions. So just answer the question and you're done. Okay, so I'm going to give you guys about let's say 30 minutes to work on 8-3.